Okay, very first video of the year is lesson 1, practice problems. So number 1, here is a diagram of a straight edge and compass construction. So here's the diagram. Straight edge and compass construction means that these circles were created using a compass. And these lines are straight lines because you used a straight edge. That's what that means. C is the center. So C is the center of one circle, and B is the center of the other. Okay, so the big circle, center C, little circle, center B. Explain why the length of segment BD, that's this right here. So explain why this is the same as this, AB. Okay, so why is this the same as this? Well, you need to know about circles. So I'm just gonna draw one for you real quick. Show you how a circle is built. Now the distance between the center of a circle and any point on the outside edge of a circle. So let's look at this one. So the distance between the center of this circle and any point on the outer edge of the circle. So the distance between C to like here, C to there, C to there, C to there. The distance from the center to the outer edge is known as what's called a radius. Now, the way you can use the compass is the distance from the center, which is going to be the sharp point, to the pen or pencil or whatever you decide to use. That's going to represent the radius. Now watch this. Like, imagine this is the center. There's going to be a circle that goes around like the center, and the distance is going to be from the point on the compass to the pen on the compass. That's going to be known as the radius. So I'll draw one myself just so you can see firsthand, and then you can also see how I use a compass. I kind of like the rotation of the paper myself. If you notice that, I rotate the paper. The one downside is you really gotta like clear your desk space if you're gonna go that route. But you'll see the center of that circle I just drew is like right here. Usually makes an indentation. So basically you connect the center to any point on this circle. Talking about, I went a little long on that line, but that's okay. So the center to like any point on this circle. These are going to be known as radii. Like this one and this one here. These are that's a radius. So the plural for radius is radii. So you automatically know that this one has the same length as this one because they're both a radius of the same exact circle. See, I didn't change the compass at all during the construction of the circle. See how they're the same length there? So what that means is any of these here are going to be congruent or the same length. So literally any radii of this circle, so starts at the center, ends at a point. So let's just say let's use my last name. Try to keep it fun. Fisher. So FI and FS will be the same length. FH and FE will be the same length. FR and FE, FS and FR. They'll all be the same length because they're all radii of the same circle. So that's the big concept that you need to know, is that radii, that's the plural of radius. So the big concept is like any radii of the same circle will have the same length. And let's talk about the definition of a circle. So you all know what a circle is. Obviously, you can recognize what a circle is, but the circle is the set of points that are all equal distance from the center. So the circle is just basically the set of all points. So imagine these are all points, right? On this circle center C. So all these are points on this circle, this bigger one. These are all these points are the same distance from the center. That's technically what the definition of a circle is the set of all points equal distance from a center. So why is BD the same as AB? I hope I gave you enough tools to solve that one. You're going to have to write at least one complete sentence. And I'll give you some words that you want to use. You probably want to use circle, and you want to use the word radius, and then you probably want to use the word length. So if you can come up with a sentence using the word circle, radius, length, and then radii would really impress me. If you could use radii, that'd be awesome. That's the plural of radius. All right, let's go to number 2. Oh, and before we go on, I want to start something new this year. These are new videos. I found my old pastime. Got it back. I used to collect baseball cards as a kid. So let's talk about Tony Gwynn first. He's one of my sports heroes. When I first started playing baseball, I lived in San Diego. And he's known as Mr. Padre. This is his rookie card. I decided to order a pack of old 1983 Topps cards. And sure enough, I got a Tony Gwynn rookie. Pretty psyched on that. Number 482. He died when he was 54. You'll see me wearing his jersey sometimes. But this guy, I think he won 8 batting titles. I can't remember exactly. But legend, Hall of Fame, 2007. One of my sports heroes. So we'll start with Tony Gwynn. All right, cool. Okay, number 2, Claire. Claire used the compass. Here's a compass. Boom, compass, circle master. So Claire used the compass to make a circle with radius the same length as the AB. So you may be like, huh? So radius. So this circle is obviously the circle she built. And the distance from the center to the outer edge is the same length as the AB. That's what that's saying. So literally any one of these from the center to any point on the outer edge of the circle is going to have the same length as AB. And watch this. I'll show you. It's probably right on, I'm sure. At least I hope. Okay, so you got, sometimes you test it like that, but yeah, you'll see That shakes out. So all the points on the outer edge of the circle, so any point on the outer edge of the circle to the center will have this length, which is called AB. And that's a segment. A segment is point to point with a line in between them. Anyway, she labeled the center of this circle C, which is right here. There's C. Which statement is true? So they said which, so that's a hint that they're looking for probably just one correct answer, A, B, C, or D. So let's just look at it. Is A, B, this one, is it greater than C, D? Well, remember, every single radius is going to be AB. Is this a radius? I don't know. AB equals CD. Does AB equal CD? I mean, what do you think on first glance? AB, is it greater than CD? I mean, is AB greater than CE? Oh, excuse me, I made a mistake. Is AB greater than CE? So it's the starting point and ending point, CE. So is AB, is it bigger than this? These are just like, you just need to know kind of what these statements mean, really. And then last but not least, does AB, does it equal? Is it the same length as CE? I mean, does one look bigger than the other? So you could just use like logic on this one, but just circle one answer and you'll be done. All right, cool. So 12 minutes, 2 problems, so 6 minutes per. Not too bad. You can easily spare 6 minutes to do a problem. It's no problem. Okay, so here we go. Number 3. The diagram, so this whole thing, was constructed, like built, essentially, with straight edge. Here's a straight edge. And compass. Here's a compass. Tools. Okay, cool. That just means all the circles are perfect. And then these lines were built with like a straight edge. So like the edge was straight. So straight lines. Okay. Points A, B, C, D, and E are all on the line segment CD. So all the points are on this line segment CD. Now remember, a line segment, point, line between them. And I'll just correct for human error, draw your points real big. This is known as a line segment. So 2 points. And then this line, starting, ending point. Okay, so 2 points, and then there's basically a line in between them. Okay, so your job is to name a line segment that is half. What does half mean? It's like 10, half of 10, 10 divided by 2 is 5, right? Okay, so name a line segment that is half the length of this one. Ooh, explain how you know. Okay, so remember, a line segment, careful, is a starting and ending point. So there's going to be 2 letters. So you got to pick 2 letters. So a line segment, starting and ending point, that's half of CD. You don't even know. Like your first instinct might be, oh, let me measure it. But you don't even need to do that. And I'll tell you why. If you look at this circle, center B, this circle right here, you're looking at here. What's the radius? well, it's either BE or BA, right? Radius represents this. Center to outer edge. So you could call the radius BE on this circle, or you could call it BA, this middle circle. Let's look at this one. Center E, right? There's a circle right here. Clearly the center is right there, E. The radius of this one is also BE. Weird. So this circle, the radius is BE, right? This circle, the radius is also BE. Starting point, ending point. Let's look at this circle. Center A, the radius of this one, AB. Wait a second, the middle circle, the radius is also AB. So that means that this AC or CA, let's use 2. I like using 2 for some odd reason. That's going to be the same length as this. It's going to be the same length as this. And it's going to be the same length as this. These are all, like ED is going to be the same length as EB. EB is going to be the same length as BA. BA is going to be the same length as AC. That's basically what you can deduce from this diagram. And it's based simply on knowing that radii of the same circle will always be congruent. So they like overlap. So like, boom, that one's going to be the same as that because they're both radii of the circle center A. Let's look at the middle circle. That one's going to be the same as that, right? And since they're all the same, I mean, you can say that they, like this one is the same as this one. Or to be specific, AC is the same as ED, right? So we got to figure out, all right, CD. Let's just count how many radii form CD. You got 1, 2, 3, 4. So when you identify 2 letters, you got to find one that's half of 4 of these. What's half of 4? 2. So pick one of them. Starting point, 2 letters. Starting point, ending point. That represents 2 radii. Cool? Okay, you pick. All right, number 4. This diagram right here, this one, was constructed, built. How do you construct things? You use straight edges and compasses. Okay, so this diagram here was built or constructed with straight edge. Straight edge. If you're wondering what a straight edge means, like the edge is straight. And compass tools, meaning the circles are perfect circles with centers and radii. In this case, this big circle, the radius is AB. AB is the radius of this bigger circle. If you look at the smaller circle in the diagram, that's CD would be the radius, or CA, or CB. Or you could flip them. You can call them AC, DC, BC. But anyway, this diagram right here, let's not get too far ahead of ourselves. The diagram was constructed with a straight edge and compass. A is the center of one circle, the bigger one, and C is the center of the other one. So A, let's just read it. We don't even really know where they're going. Just go slow, read it, and figure out what we're trying to do here. So the 2 circles, there's 1, there's 2. Intersect, that means like meet. Think about a street intersection. Streets meet. Typically streets are like this, and they meet here. But 2 circles intersect at point B. So, okay, cool, yeah, definitely. The smaller circle intersects the bigger circle at this point, which is B. label. Label, label, label. That means there's another intersection point. Like, where else do these two circles meet? That's what an intersection point is. So where does the small circle meet the bigger circle? And then you have to see how they have points here? Like, you want to label like a point, like so. And you want to call it E. But the game is, where do you put that, right? So you have to label where the two circles meet the other one. There's only one other one, and you have to call it E. That's what they're asking there. All right, B. How does the length of segment CE, so wherever you decide that point is, how will that compare to the length of segment AD? Well, here's what you need to know about AD. AD is known as a diameter. Diameter, keyword, keyword. A diameter applies to circles. Here's the other way you can do a compass move. You can just fix your fingertip on the top here. These are the compasses I have in my classroom, but highly recommend these, teachers. They're awesome. But you got to put pressure on the point, or the center, I should say, the sharp point, and then you just like keep the paper fixed, and then you move the compass. So you could either hold it and move the paper, or you could fix the paper and move the compass. It's up to you. But a diameter of a circle is basically, let's pick any point on the outside circle, right? Here's your center. You can tell because it made an indentation. So here's how you could make a diameter. You would just use a straight edge, and it's a line or line segment that goes from one outer edge through the center, and then it keeps going, and then it goes to the other outer edge. This right here is a diameter. Now, what you already learned is that any of these red lines are known as, this is a radius, this is a radius. But you know that all radii have the same length if they're in the same circle. So like this one is going to be the same as this, which is going to be the same as this. There's also a radius here. So you're automatically going to know that all these red lines go from the center of the circle to points on the outer edge of the circle. So these are all the same. And because we did 2 hash marks on each of these lines, that is the way to label like lines that are the same length. So let's look at this. Isn't that a radius? So boom, that's gonna be the same as this, right? From here to here. This is a radius right here. Boom, from center to outer edge on the circle. So how does the length of CE compare to the length of AD? Radius, right? These are all radii of the same circle. All radii of the same circle have the same length. That's what you need to know. Definitely need to know that. So all radii have the same circle, have the same length. So let's look at how does CE compare to AD? You tell me. Okay, hopefully that helped. That was 25 minutes, 4 problems. We're looking at around 6.5 minutes or so. That's about what you should expect. 6 minutes per problem or so. Lesson 1. And if you're still learning, it might take a little longer. So now you know. All right. Go Tony Gwynn. One of my sports heroes. Mr. Padre. Try to keep his legacy alive. Woo. All right.